Right, this is the first lecture on Fourier series, which we've started. We've now finished differential equations. There's no more of that. There'll probably be some examples in Easter as more revision, but that's about it. So we've got the introduction to Fourier series. Right, now first of all the definition. As you can see here, we've got a little animation. What the Fourier series does is it estimates the values along a line. So as we put our Fourier series in, I'll just explain this first. This is our Fourier series. If you have a function, this is our function f of t, which is the Fourier series. So to find this, we have a naught, which we've got here, over 2, and a naught is 1 over pi times the integral from minus pi to pi of the function that you want to find. The f of t, that's not this f of t, the function that you're trying to find the Fourier series of, plus the sum from n is 1 to infinity of an cosine nt. An is the function that you want to find the Fourier of. We've got 1 over pi again times the integral from minus pi to pi cosine nt. Remember, this isn't the same as that. Now this cosine is not this cosine. Right, and then we add bn sine nt, and this is all in the brackets, this is all the sum. Bn we have here as 1 over pi, the integral from minus pi to pi again of the function you want to find the Fourier of, times sine nt, and n in all these cases is just a scalar, so it's a real number. Right, now going back to this, if we start in n is 1, as we progress closer to infinity, this line, this red line, which is the estimate, if you can see it, it gets closer to the line and it gets a better guess at the line. And obviously it's got drops because it doesn't know what to do when it gets to the points, so it drops right down. Right, an example. Now this is just a simple example. There will be plenty more examples in the other lectures, so it will progress quite easily. Right, with this we've got the function we've got the function t, a nice simple one. We want to find the Fourier of that. So first off, we need to find the an, the bn, and the a naught. So we have the an here, which if we put t in, we have 1 over pi times integral from minus pi to pi of t cosine nt dt. And if you apply the rules, you know, u dv dx equals uv minus the integral of v du dx, if you apply that, which it gets very long. Now that's the problem with Fourier series, it's very, very long to do examples. It took some like 2, maybe 3 pages to do examples with me before. Certainly it was a nightmare to type out, so I just left that. And you will get 0 in the end. If you do not, then just message somewhere or email me. Bn next, we have 1 over pi integral from minus pi to pi of t, because we've got t, sine nt dt. And if you go through with this, you will get minus 2 pi over n times minus 1 to the n. Now this minus 1 to the n, that comes from the fact that once you integrate everything, you'll get a cosine nt. And when you put the pi in, cosine pi is minus 1, but for every even multiple, so because we've got the n, we have, if it's cosine 2 pi, for example, that's 1, cosine 3 pi is minus 1, so it alternates, so we put our n up here to make it positive and negative. And these will all come, this should come out perfectly. I did test it as well. This one, the easy one, some people like to do this first, but it's like a nice little relief at the end. A naught is 1 over pi, the integral from minus pi to pi of t, which works out to be 0 because you'll get pi squared minus pi squared over pi, which is just 0. Right, and now the final part, you just have to put it into the formula. So we remember our formula here. we've got all the values we need. We've got a0, an, and bn. We put them in there, so we've got 0 plus the sum n equals 1 to infinity of 0 plus minus 2 pi over n times minus 1 to the n cosine nt. There should be another bracket at the end there. And then go down a bit more, get rid of all these zeros, and you'll end up with your Fourier series is f of t is the sum from n is 1 to infinity minus 1 pi, minus 2 pi, sorry, over n times minus 1 to the n sine nt, and that's how you solve a simple Fourier series.